Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will understand and calculate limits. So limits are very important in calculus. What we're going to end up doing is limiting the distance between 2 points on a curve. So that might not make sense now, but to be able to do that, we need to understand how to calculate limits. So we usually see it written like this. This lim just means limit. This is read as the limit as x approaches 1 of 2x. What this is saying is, as x gets closer and closer to the value of 1, what happens to the value of 2x? Well, obviously, 2x is going to get closer and closer to 2. So here I've drawn the graph of y equals 2x. It goes through this point here, 1, 2. So this is essentially saying of this graph y equals 2x, as x gets closer and closer to 1, what happens to the y value? Well, as x gets closer and closer to 1, the y value gets closer and closer to 2. As x is getting closer and closer to 1, the y value is getting closer and closer to 2. That's what we mean by limits. So when you're calculating a limit, just start by seeing, can you substitute this number into the function? So if I wanted to calculate the limit as x approaches 3 of x cubed minus x squared plus x minus 1, I just see if I can substitute x equals 3 into this function. Well, I can. I can substitute 3 very, very simply. So what this is saying is, as x gets closer and closer to 3, the value of this gets closer and closer to 20, which is 27 minus 9 plus 3 minus 1. So that's all there is to limits like this. But sometimes you will not be able to simply substitute the value that x is approaching. So if I, for example, take the limit as x approaches 0 of x squared plus 6x over x, I would have a problem if I tried to substitute x equals 0. I would get 0 over 0, which is undefined. So what I can do is I can try to make this easier to work with. What I can do is factorize the top, and then I leave the x on the bottom. Now I can cancel out the x's because they're both being timesed. So this limit as x approaches 0 of this, that's the same as the limit as x approaches 0 of x plus 6. So, substituting in x equals 0 to this, I just get the value 6. See, the thing is, for this function here, x cannot take the value 0, because then I'd be dividing by 0. But what we're saying is, as x gets closer and closer to 0, even though it can't equal 0, the value of this gets closer and closer to 6. If you were to substitute in a very small number close to 0, like 0.001, if you substitute in here, you'd get an answer that is close to 6. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.